about version control in general. Let's talk a little more about Git specifically. So we can break down these commands that we've been doing. So everything to the left of the dotted line here is happening on our laptops. So the commands we've been using, add and commit. Let's break down what they're actually doing. So your files as they are right this second, what's actually in your Christmas folder, that's called your working copy or working directory. That's the current state of things. That is what the code looks like right now. And right now, I haven't actually made any changes since my last commit, I don't think. No, I haven't. So my working copy actually matches my history. But as soon as I make any change, so let's have a look at the README real quick. I don't actually say anything about what Christmas is here, so let's just add a little paragraph here that says, first project for Extern Bootcamp 2018, session 3. Now I've made a change since my last commit, and if I type git status, I see changes not staged for commit, modified readme.md. So those changes to the README are now in the working directory, but they are not in the actual history of the project. So that third thing that I've marked head there, I kind of wish I'd marked it history, but that's the actual log. Those are my commits. Those are the things that are permanent. And right now there's a difference between that and my working directory. So that's why git status shows me that thing in red. I have a change in my working directory that is not yet in my history, which is fine. Maybe I'm not ready to commit it yet. But if I were, there's a step in between those two things. There's a step in between where you've made the changes and where it actually becomes a permanent part of your history. You have to first stage that change. And you'll notice, use git add to update what will be committed. So basically, it's sort of a draft of your next commit when you type git add. And that moves it to what is known as the staging area or the index. So when you type git add, you're taking the changes that you've made from your working directory and you're adding it to the index or to the staging area. It's like a practice run for your next commit. You haven't committed yet, but you've now told it, okay, prepare to commit this thing. And it may seem strange that those are two steps, but there's a pretty good reason for it. So let's do git add. And again, I could say git add one file at a time, or git add dot to just add everything that's changed. And that's kind of the key there. You can stage just a little of what you've changed. If you do find that you've kept working past the point when you probably should have added something to your history, you can stage things selectively and only commit some of the changes that you've made, which is easier to do with a graphical interface, but possible to do interactively at the terminal. It's also useful if you're going along and you're like, okay, I haven't really finished a feature yet, but I know that I want this file to be staged. So you go ahead and stage that file with git add, but then you keep working. So then you're in the situation where you have some stages, some files that are staged and some that are not. So if I make another change right now, I've already staged one. Let's do a git status. And we see changes to be committed, modified readme.md. So now that is in my staging area here because I already ran add. But if I make even more changes to this file or to any other file, this project uses vanilla JavaScript /ES 2015 plus. Now what? Is that staged? Because I staged that file. But no, if I do a git status, changes to be committed, modified readme. Changes not staged for commit, modified readme. So some of those, so the same file can actually be kind of in two states. The file as it is right this second with both changes, that's in the working directory. Now with one of those changes, it's already in the index. So actually git is, what happens is, if we look at this hidden folder. So everything Git does, it puts in this hidden folder called .git, which you don't ever need to actually worry about. But if you're interested, your real history lives inside this objects folder. That's where it puts stuff. But there's this file index that kind of keeps track of what the deal is with every file that's in there. Now, if it's just in your working directory and you've never paid any attention to it, index doesn't give a crap. They're not paying, Git is paying no attention to that file yet. But as soon as you've ever added that file at any point, it becomes a part of the story. So when you add a change, it actually goes ahead and adds it to objects. It stores the change in the actual repository. You just haven't stuck a label on it. So when I said it's kind of a draft of your next commit, that's what I mean. It actually does put it in your repository. You just haven't stuck a label on it yet. And it keeps track of that fact in this index file, which you never really need to know if you're not interested. But that's what's happening. So your working directory always just has whatever the most up-to-date thing is, even if you've never saved it, or, I mean, well, not saved it, but committed it. But as soon as you add it, it starts paying attention. It adds it to your objects folder somewhere in these complicated-looking hashes. And it keeps track of the fact in index that that thing is only staged. There's not actually a permanent long-term reference to it. And then as soon as you say commit, we'll go ahead and stage all of this now. Update README with a project description. Now, it's updated so that that checkpoint has a label. It's now a permanent part of it, and the index is saying, okay, that's no longer staged, that's the real deal. And at the moment, there's nothing in our working directory that isn't already permanently committed to our repository. So this is more technical than I usually get with this, but I'm trying to experiment to see if it's more or less helpful to get kind of technical with what happens when you run these commands. So your working directory is the current state of your files, whatever that may be, committed or not. When you need to commit, you must first stage your changes to tell it what to commit, because it's not necessarily going to commit everything that's in your working directory. You have to tell it. And then commit makes it a permanent part of your history. But again, all of this is just happening on your laptop. To sync it with the cloud, you have to do more. Yeah. What are the other command line arguments? One of the other ones is actually A. So you can actually say -am, I think. Or do you have to say -a-m separately? I think this will actually tell us. Let me test something real quick. Yeah, I need to... -a, right? So -a actually adds and commits all in one step. Other than that, I don't really. Well, there's actually there's a lot. So another one that's kind of useful is --amend, which would change your last commit. So if, for example, you committed and you realized your commit message was terrible or had a typo or something, you could amend the previous commit that way, or you left a file out. You accidentally broke the build with your last commit, and if you committed one more file, then you'd fix it. You could amend the previous commit using git commit --amend. Now, if you've already pushed, you're going to have a problem, but that's kind of another story. So yeah, there's a lot more you can do with that command, but -m is important. If you don't put -m and you don't give it a message, it'll actually open your default text editor and make you put a commit message. And one of the commands that you did as part of setup was to make sure that that opens Visual Studio Code instead of Vim, because if you're not familiar with Vim, you're going to be confused when that opens by default because you don't even know how to exit if you were never taught that. So anyway, I don't actually want that change. What did I do? I added this nonsense. Very good. So again, all of this stuff so far is happening on your local machine.